Today's lesson, second part of section 6.6 on solving log equations this time instead of exponential. So let's take a look at this first equation. And I might ask you, what strikes you about this equation that we have seen in the past? And that is that we can utilize the logarithmic property of equality right off the bat. Both of these are natural logarithms. So what that entails is that the value of the natural logarithms are what's left over. Now what you have to do is just simply solve this equation. So let's just say I move this x over here. So I've got 3x minus 7 is 5. Add 7 to both sides. Divide by 3. Now, what you need to do in these problems is when you are finished, you gotta remember something. The graph of a logarithm is the inverse of an exponential. So it looks something like this, where the the y-axis is an asymptote. So the domain for these graphs is where x is greater than 0. So substitute your answer back into the original problem, this 4, right here and right here. Let's make sure we don't have 0 or a negative number. Otherwise, there's no solutions to this. And we're good here. So 4 is the answer. All right, let's go ahead and take a look at this one. How would you go about solving this equation? So as we take a look at this equation, it appears as though it might be impossible to get that x alone. But if we could implement one of our logarithm properties, then I think that we would have a chance to get this done. So what I'm looking at is the fact that this is addition. Because it's addition, I'm going to use my logarithm property and know that I can take the two values and write them as a multiplication statement, which could be something like this if you do a distributive property. Now my question for you is, what would you do next? Well, what you might want to do is rewrite this as an exponential function, knowing this is a base of 10. So this would be 10 to the 2 equals the value of the logarithm. And 10 squared is 100, right? So I think what I would do at this point is, notice this is quadratic. And now we can try to solve it. I think what I might do is divide everything by a 2. So you're going to get 0 equals x squared minus 5x minus 50. Maybe we can factor this. Don't know if we can, but let's try it. All right, let's get two numbers that multiply to give you negative 50, but they add together to give you negative 5. About negative 10 times positive 5. That would work, right? So knowing the zero product property, we have two answers, 10 and negative 5. The question is, do they actually represent answers? Let's take this 10 first of all. Go back to the original problem. Now let's see. If I put a 10 in here, let me just superimpose it. So we'll put a 10 here. That would be okay. And put a 10 here. Yes, that would be all right. So 10 is an answer. What's the other? Negative 5. All right, let's try that. So if we put a -5 right there, that'll give you a -10. Impossible. That's out of the domain. So let's go down here. Oops. Let's go down here. That one is extraneous. The only answer is 10. Okay. We've got 4 questions we're going to do here. Everybody give the first 2 a try. Let's see how you do. Let's take a look at number 5. What I would do right off the bat, logarithm property of equality. Then what I think I'd do is solve this. Take that over, it'd be 5x minus 4 equals 11. Take the 4 over there. Check your answer. Put that 5 back up in the original problem. It'll work. That's good. Number 6, I would rewrite it as an exponential function. 2 to the 5th power equals x minus 6, which is 32. So I think what I'd do is move that up, back that up. Move the 6 to the other side by adding. Check your answer. And that's fine. That's good. Okay. But everybody try those 2 questions. Let's take a look at number 7. You can see we've got an addition problem here, right? So that means that we can multiply logarithms together. So it'd be logarithm of, well, may not need to write that. Logarithm of 5x times x minus 1 equals 2. Now what you could do is you could rewrite this as logarithm 5x squared minus 5x equals 2. Then we got to notice that this is a base of 10. So this could be rewritten as 10 to the 2nd power equals 5x squared minus 5x. At this point, we could say that this is actually 100. Collect everything to one side. You either divide by 5 or factor out of 5. Let's see if this factors. If not, we can use a quadratic formula. Got 2 numbers to multiply to give you -20. That add up to give you negative x. About -5 and 4. So what do we have for an answer? X equals, by the way, that's extraneous, 5 and -4, if they both work, right? So let's go put a 5 up there. That's good. Put a -4 up there. It's not going to work. -4 is going to give us some negative answers. So only 5 is an answer to that. Last question. I think we're going to go ahead and implement the same formula because we have addition, which implies we can multiply. Now I can rewrite this as x squared plus 12x in here. Okay. What do you do now? Maybe write an exponential equation. 4 to the third equals x squared plus 12x. However, we know that 4 to the third is actually 64. And now what we can do is solve this. I'll move that 64 to the other side. And what we can do now is we can try to factor. All right, let's see if we can get it done. Get two numbers that multiply to give you negative 64, add up to give you 12. All right, so we got x and an x. Okay, what might those be? Uh, 16 times 4 would probably work, wouldn't it? 16 times 4 is 64. So, let's see, our final answer, negative 16 and 4, but we need to check those. Let's try that negative 16 up here first of all. That's no good. Let's try the 4. That's okay, so that would be our answer.